Hi there. For this video, we'll be solving linear inequalities. But before we can go on to that, a good question to ask is, how can we find all values satisfying an inequality? Well, it's easy if we have, say, x, and we simply have x greater than 3. Since this is very straightforward, we know that all values of x that satisfy the inequality is simply x is greater than 3. But what if we have, say, 2x plus 5 over 11 is less than or equal to 2 minus 5x, like that. So now it's not easy to see immediately what values of x satisfy this given inequality. So this is what we'll be trying to figure out in this video. So there. So before we dive into our examples, take note that solving linear inequalities is just like solving linear equations. So basically, the idea that we use in linear equations will be similar in this one. Like, if we have a equals b and we add c both sides, then we'll simply have a plus c equals b plus c. Or if we have a equals b again, then we know that if we move this to the left side, we'd obtain a but the negative version of b. So that is a minus b equals what's left on the right side is 0. So similar things apply in linear inequalities. It's just that we'll have a inequality sign or symbol out here. But take note that when we multiply a constant to an inequality, we'll have actually two cases. So say we want to multiply both sides by a constant c, wherein c is a real number. Then we have, if c is positive, then we'll simply have ac is greater than bc. So there are no changes in the inequality out here. But if we have c is less than 0 or c is negative, then we'll have AC is less than BC. So when we have a negative value or we multiply a negative value, always take note that the inequality sign or symbol out here will reverse. And why is that? Well, if we have, say, 1, and we know that 1 is less than 2, if we multiply this by their negatives, or say we multiply negative 1 out here, then we'll obtain negative 1 on the left and negative 2 on the right. And clearly, negative 1 is already larger than negative 2, since let's clear out some space here. Since if we have a number line out here, this one is 0, these are the negative values, positive values. We know that the one out here with the higher positive part, in this case 2 is higher than 1, in terms of negative, it is actually less than or lower. Indeed, if we extend this further, negative 3, negative 4, negative 5 are all lower or lesser values than the negative one out here. So that is how it works. I hope you got the message across out there. So So just take note of these two cases, especially this case out here. So whenever we multiply a negative, we always reverse the sign of the inequality. So there. Now we dive into our first example. This example, we have x plus 2 is greater than 4x minus 2 over 3. So just like how we do linear equations, let's try to solve this one. First, note that we can multiply, let's move this one. We can multiply 3 both sides to eliminate this one out here. So we'll obtain on the right 3 times x plus 2 is greater than 4x minus 2. And then from here, we simply distribute the 3 out here to obtain 3x plus 6 is greater than 4x minus 2. And similar how to solve equations, our goal is to eliminate all the values, or rather isolate x in one side of the inequality this time, not equation. So we'll be able to clearly see the values of x that satisfy the inequality. So doing that, we move 3x to the right and we move negative 2 to the left. So we'll obtain 6, and again when we move to the left, we change the sign. So we'll have 6 plus 2 is greater than 4x, and 3x will become negative 3x. Now simplifying both sides, we'll obtain 8 on the left side and 4x minus 3x is x on the right side. So just rewriting this, we can rewrite this as x less than 8. It's like rotating this one. And so we have this inequality out here. So all values of x that satisfy the given inequality are x that is less than 8. If you want it to write in an interval notation, which is oftentimes better since it looks nice, I guess, then this will be negative infinity to 8, with 8 not included, since we have a strict inequality out here. And that is the answer for this first example. Let's have this next example. In this case, we have a chain inequality. Since we have two inequality signs out here, or symbol. And note that if this is the case, what our expected value out here is, if you recall our number line, and we have here A. If we have here A and B, then if we have a chain inequality, most likely our inequality will be something like this. So our goal is to eliminate the variables on the left and right side and just make it a constant value. And in the middle, our goal is to make it just a single variable. So our final answer should look something like this, with a constant here and b. And the signs, it can be equal to or there. So something like that. So that's a good way to visualize how will we attack this problem. So first, to eliminate the this denominator out here, since it's not really good looking, I guess, we can multiply 3 both sides to obtain 3 times y minus 5 is less than or equal to y plus 5. And on the right, we'll have 3y plus 1. Simplifying, it's not 3y plus 1. It's 3 times y plus 1. Then distributing this 3 on the left and right side, we'll obtain 3y minus 15 is less than or equal to y plus 5 is less than 3y plus 3. From here, again, our goal is to make these sides a constant. So we need to eliminate the variable. So fortunately, since they are the same, we can subtract 3y to both sides, or to all part of the inequality out here, including the middle, so don't forget this one. And there. So we'll obtain on the left side negative 15 is less than or equal to y minus 3y is negative 2y plus 5 is less than 3. And now from here, we're actually kind of close to our desired outcome, since if we look at it, we have eliminated the variables on the left and right side. And in the middle, we still have our variable. So just need to manipulate this further. So next thing that we'll do is we'll subtract 5 to all sides to eliminate this 5 out here. So 15 minus 5 is negative 20, less than or equal to negative 2y, less than 3 minus 5 is negative 2. So let's remove this first. Let's rewrite this much better. Negative 20 less than or equal to negative 2y less than negative 2. There. Now, what's left is to multiply negative 1/2 both sides so that we can remove this negative 2 out here. And take note that we are multiplying a negative value. If you recall in the previous part of this video, when we multiply a negative, we reverse these signs. So this will become negative 20 over negative 20 times negative 1/2 will be 10, reversing the sign. So we'll have here greater than or equal to, then negative 2y times negative 1/2, that will be y, and reversing the sign. And on the last one, negative 2 times negative 1/2 will be 1. So just rewriting this again, we'll have this. So basically, I just rotated it again to make it look more of what we want. And this one out here is actually the answer. So all values of y that will satisfy the given inequality are from from 1 to 10, with 10 included. Or in interval, we write this as 1 and 10 with 10 included. So it's a square bracket. So that is how we solve inequalities that are chained. Or we have two inequalities here, so we say that it's chained. There. Let's go on to our final example. Now for this one, you can verify that we can't really use the method that we did a while ago, wherein we solve this simultaneously, since again, if we aim to remove the variables out here, we will be needing to subtract z out here, and we'll be needing to add z out here, so it does not match. Unlike in the previous one, we are lucky that it matches. So what we do instead is we split this inequality into two. So this will be the first, this will be the first, and this inequality will be the second. So by writing that down, we'll have here 2z plus 2 is greater than z minus 1, and 2z, oops, this is a different color, and 2z plus 2 is less than or equal to 8 minus z. So there we split the two parts of the inequality, and we solve these two. So solving for the first one, we move the z to the left side and the 2 to the right side to obtain 2z minus z is greater than negative 1 minus 2. Simplifying, we'll have z is greater than negative 3. On the right side, moving the negative z to the left side and 2 to the right side, we'll have 2z plus z is less than or equal to 8 minus 2. Simplifying, we'll obtain 3z is less than or equal to 6. Then we divide 3 both sides, or technically we multiply 1 over 3 both sides, and since 1 over 3 is positive, there will be no changes in the inequality symbol. So we'll have z is less than or equal to 2. And so we have two inequalities. But this isn't the final answer. What we'll do instead is we will get the intersection of these two inequalities. So if we have a line out here, a number line, let's not include that one, and we have here 0, out here negative 3, and around here 2, so just estimates. If we plot this one, this z is greater than negative 3, then it will be this one. Yeah, apologies for the ugly line out here, but that is how we do it. And note that negative 3 is not included since we have a strict inequality out here. For the other one, this one, z is less than or equal to 2, then we know that 2 is included and it is less than. There. And again, our goal is to find their intersection. So their intersection is actually this one out here. It's not quite easy to see in the screen since the two lines overlap, but if you're working this one on your papers, I guess, you can easily see which part of this line overlaps, since at that part, that is where the intersection of the two lines occur. So therefore, this one out here is actually z is from or between negative 3 to 2 with 2 included. Or in solution set, we write that one as negative 3 to 2 with 2 included. So we square bracket. And that is the answer for this problem. So the values of z that satisfy the inequality only ranges from this interval. So there. to end this video, here are two exercises that you can work on. For this one, simply solve this like linear equation. And for this one, although you also solve the second example just like a linear equation, take note that we can't really do the method that we did in the second example wherein we solved this one simultaneously, because we'll be needing to subtract b out here and we'll be needing to subtract 3b out here to eliminate the variables, and it does not match. So you'll be using the split method, wherein you split this one out here, then this one out here, and get the intersection. So those are my hints for these exercises, and feel free to comment down below your answers to these in the comment section down below, as well as your solutions if you want to. So that's it. I hope you enjoyed this one and you learned a lot from it. So yeah, that's all for this video.